Make sure that it is recording. Yep, we're recording. Perfect. Give a second for the Elmo to warm up and get on. We'll begin again now. Getting these last ones done for you. So it should come on in, I don't know, we'll say 5, 4, 3. Hey, a little earlier than that even. Alright, folks, sorry about that. Let's take a look. Going to zoom in just a little bit. Explain why the results of the following survey are likely to be inaccurate and suggest a way to improve the accuracy. Random sample of town residents survey asks, are you in favor of special tax levy to renovate the sad state of the city park? Biggest problem is that they use sad state in their survey, which means already implying that it's terrible, making people already put that in their minds. It's going to skew or have a bias in their survey. So first of all, they should take out the word sad state and ask, are you in favor of a special tax levy to renovate the city park? Something like that would be better. Mr. Culberson, the owner of a sporting goods company, conducts a one-on-one interview with a random sample of employees to have them rate how satisfied they are with the quality of the goods they sell. Okay, this is a one-on-one interview with your boss. How exactly honest are you going to be with your boss? Good question. Good. Maybe not quite as honest as you would as if it were, say, like anonymous thing that you could tell, or a survey that you're filling out anonymously. But with your boss in right there, and you're telling him, I don't think you're going to be that honest. Determine whether each research study is an observational or an experiment. So researchers found that of patients who had been taking a bone loss drug for more than 5 years, a high percentage of patients also had an uncommon type of fracture in the thigh bone. That is an observational study because they just took research that was done, that had been done on the bone loss, and then they had an uncommon type of fracture of the thigh bone. So it's an observational study. They identified the population parameter. Basically, their population parameter would be how many had people that had taken the bone loss drug if they had this thigh bone fracture. So bone loss drug, did they have the thigh bone fracture? Okay. 27. Researchers want to know the effect of vitamin C as a dietary supplement on blood pressure. Half of the randomly assigned subjects take one 1,000 milligram tablet, while the other half of the subjects take one placebo. So you have two groups. This is going to be an experiment. And our parameter of interest is the effect of vitamin C on blood pressure. Or more likely, does vitamin C help a person have not high blood pressure? Consider the situation where a company is testing a new pair of shoes. They give 20 runners a pair of their redesigned shoes and 20 runners a pair of the previous model shoes. After 1 month, they'll be testing the amount of wear on the shoes. Choose true or false for each of the statements. Explain why. Parameter of interest is how far each person ran after each month. That is false. The parameter of interest is how well did the shoes wear. It is not a potential problem that tests. We do not know how much each person runs in a week. In a sense, that is also false because you could have a person that puts those shoes on and does like nothing, while another person puts them on and runs 10 miles a day. You're going to have lots of different wear on those shoes, and that would be definitely something you want to know. The desired hypothesis for the shoe company would be that the older shoe worked better than the redesigned ones. Not necessarily. I'm going to have to say false on that too. The only reason they're redesigning things usually is to try to improve or become better. So I would think that their hypothesis would not be that the older shoes worked better, but that the redesigned ones would work better. All right, let's go through these ones here. 31. Local company, the age of all new employees hired in the last 10 years, approximately normally distributed. The mean is 35, standard deviation of 5. So once I hear normally distributed, I'm going to go ahead and draw my normal curve. It says that the mean was 35. I know I go 1, 2, 3 out, 1, 2, 3 out. Standard deviation of 5, so that's 40, 45, 50, 30, 25, 20. This is 34, 34, 13.5. 13.5, 2.375, and 2.375. So now it says find the percent of new employees that are at most 25 years of age. At most would imply that they're 25 and below. So down here, so I'm going to have to say 2.375% and mark the region. So to mark it, I would just color that in. That's how you would mark the region on a curve. Oh, in pink. I don't think I have. Oh, wait a minute. I got pink highlighter. We'll see if that works. That's that part of the region. Okay, find the percent of new employees that are no more than 40. No more than 40, again, would imply that it goes up to 40, but they have to be less than. No more than 40 is up to 40, but not more than that. So you add all these together. 34 plus 34 is 68. 68 plus 13.5. 68 plus 13.5 plus 2.375 is 83.875. That's the percent. Mark that on in yellow. So let's see if I have my yellow highlighter. I do. So then I would be marking all of this right to here, up to the 40. And it says find the percent of new employees that are at least 20. So at least 20 would be from here up. Well, if you add all this up, from here up, you get 99.975%. That's what you get. So there it is. And then mark this region on the curve in blue, so the whole thing would be blue. It says if you were to choose one employee random, what's the probability his age would be less than 30? So here's 30 less than. I would add these two up right here, 13.5 and 2.375, which gives us 15.875% probability. If you were to choose a new employee at random, what's the probability his age would be between 27 and 43? 27 is like right here. 43 is like right here. So again, there's going to be more over here than in here. So I can't just cut 13.5 in half. So maybe I say that there's there's 8 over here and 5.5 here. Same thing here, 8 here and 5.5. So 34 plus 34 is 68. 68 plus 8 is 76, plus 8 again would be 84. So I'd say that was 84%. And that's kind of what you're looking at doing right there. Okay? If you're not quite exact, that's okay, but you can't use all the way from here to here. You can't use that because part of it is not included. Use a sampling distribution from Unit 10, Day 4 notes to answer the following. Jenna wants to know the percent of Lone Peak students. Problem's too expensive. She goes around 30 randomly. Jenna. So remember, this is where you're going to figure out where 10 out of 30 lies. It's either going to be the 30% one or it's going to be the 40% one. You got to pick which one you want to do. And then from there, if you look at the 30% one, I think the lowest number on the 30% one, I don't have the notes right with me. I think the lowest one, though, if I'm not mistaken, is like 4. So that'd be 4 out of 30. And the highest one was like, I think maybe 18. So it's 18 out of 30. So if you take 4 out of 30, you get 0.133. If you take 18 out of 30, you get 0.6. So then, to find your margin of error, so it says use the sampling distributions from your notes to determine the confidence interval and margin of error. So the confidence interval would be from 0.133, or in other words, 13.33% up to 0.6%. And then we'd find the one in the middle of that, 0.133 plus 0.6, divide that by 2. So I get 0.3665, and then from there up to 0.6, or down to 0.133, is a difference of 0.2335. So this can be plus or minus 0.2335. This number right here is your margin of error. A lot of times we write the confidence interval as this right here, okay? Or you could write it like this, 13.33% up to 6%. And then the margin of error is the 0.2335. If you do the 40% one, you're going to have a different lower number and a different upper number, but you do exactly the same process again. So I'm hoping that makes sense. If not, rewind the video, watch it again. But again, you took the lower number, which was 4 out of 30.133. Then you took 18 out of 30.6. Then to find the number right here in the middle, oh, so then I could say my 95%, this one would be 0.6%. That's a full class ticket. This would have been 60%. So write that as a percentage, would be 60%. So 13.333% up to 60%. Or we could say 0.3665 plus or minus 0.2335. You could also have written that as 36.65% plus or minus 23.35%. And this again here is your margin of error. That thing that you're plus or minus, this whole thing is your confidence interval. Okay? 38 says Mary wants to find the average wait time for students to find emphasis. Mary takes a representative sample of students that found their average wait time was 6 minutes, standard deviation of times 2. So right there, normal curve, boom, says this is 6, go out 2, 1, 2, 3, back 1, 2, 3. But 95% confidence interval is going to be from here to there. So it's 6, and then it says a standard deviation of 2. So that's going to make that 8, that's going to make that 10, that's going to make that 4, that make that 2. So the confidence interval would be from 2 to 10, or we would say 6 plus or minus 4. Either of those would be known as your confidence interval. What's the margin of error? That's the plus or minus 4. That's my margin of error. Describe the meaning of your 95% confidence interval. If you were to ask somebody, how long did you wait at the office, you would be 95% confident that their answer would lie between 2 minutes and 10 minutes. That's what that means. Last problem, Caleb found that a 95% confidence interval for the actual percent of people in Cedar Hills who shop at Walmart is 72.5 to 90.5%. What's the sample proportion and standard deviation? Well, remember, so this is the bottom part of it. This is the top part of it. So we would want to find the number right in the middle. That would be our sample proportion. So you would just take 90.5 plus 72.5 and divide that by 2. That's going to give us 81.5. That's the one right in the middle, 81.5. There's your sample proportion. Then the margin of error is the distance from here to there, or from here to there. So we could just take 90.5 minus 81.5, and that would give us 9. And then this would also be 9. So my margin of error is 9. Okay, sample proportion. Oh, that's margin of error, which remember is 2 standard deviations away from the mean. It's 2 standard deviations. So I'd have to cut this in half for one standard deviation. That means 4.5, 4.5, that makes the 9. So 4.5 is the standard deviation. You need the standard deviation is 4.5. All right, folks, good luck on the test. We'll talk to you later. Have a good one. See ya. Think that was too fast?